So now we're going to start learning the actual Python language. So what do we say? You can think of this as almost like writing a story. We're going to start with a basic vocabulary. We're going to talk a little bit about lines or sentences, and then we're going to start talking about how to put those sentences together to make a coherent paragraph, as it were. And you just have to accept the fact that when I start teaching you this stuff, it's not going to make sense for about 6 or 7 more chapters. And so just sort of bear with me, except, I remember when I first learned, it went from me confused. Holy mackerel, this is awesome. And so I expect many of you will go through that same thing. So just learn the first parts, accept the fact that it doesn't necessarily make sense in a big picture, and just bear with us, okay? So we'll start with vocabulary, we'll start to make sentences, and then we'll have little short stories and paragraphs, okay? And so this is a short story about how to count the words in Python. It's got a couple of paragraphs, and we are going to look at all of this stuff eventually. So we start with a set of reserved words. And what are reserved words? Well, they're words that Python expects when you use these words that they're going to mean exactly what Python expects to mean. And what it really means is you're not allowed to use them for any other purpose than the purpose that Python wants. It's sort of part of the contract. It's like when you have a dog and you go, what did you think of that television program? And the dog has no idea what you're saying. And then you say, do you want to wait until Saturday to go to the veterinarian? And the dog still doesn't know what you say. And then you go like, how would you like to take a walk? And then the dog goes, walk. I know what that means. And then hits the door, right? And so the way the dog sees you is blah, 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 walk, blah, 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 food, blah, 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 treat, blah, 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 walk. That's kind of how Python looks at these reserved words. When you say class, it goes class. Oh, I know what that means. Now, if I say zap, it's like, oh, zap something that you get to decide, or it's maybe a variable name. So reserved words are simply words that when you use these words in Python, and there's only a few of them, like and or del, or if maybe, pass maybe, in. A lot of these, you won't end up using them. It's just these are reserved for Python and part of the Python vocabulary. This is Python vocabulary. Now, when we move from words to sentences, you see that Python is a series of lines. A Python program is a series of statements. They have an order because the computer wants to know what next, what next, what next. So what next is start at the beginning. So I already talked about an assignment statement that basically says x equals 2. This is not a mathematical statement. This is a directive to say, take this variable 2, this value 2, this constant 2, and stick it in a location in your memory, and remember that I asked you to name it x. X is a variable, something you made up. You chose that. And so, but it's Python's job to remember it. So this says, go to whatever that x is, there's a 2 in there. Now pull that x back out, add 2 to it, which makes it 4, and stick it back in x. And so that makes this a 4. So x is a 4. And print x says, go look up that thing that was an x and print it out. And so these are like, each line has something to it. I'm using a reserved word. Well, actually, that's a function, but it's a reserved word too. And so there's reserved words and all these things, and you combine these. There are operators. Plus is an operator, equals is an operator. These things do things, and we'll learn all this stuff in time. So the basic building blocks of lines of Python. Now, as we take these lines of Python and build them up, we end up making paragraphs, programming in paragraphs. And so one of the things that it's important is I showed you how to do interactive Python. So you just type Python and you type a statement and a statement and a statement. Those get really tiring after about 3 or 4 lines of Python because you start making mistakes and you have to start over. So the better thing to do is to, as your program gets a little larger, to write a script. Put your Python instructions in a file and then tell Python to read from the file and then run the script as it's entered in that file. We tend to name these files with .py, and I've got a series of videos that you can watch to figure out how this all works. Like I said, you can type interactively to Python, and it's a great way to experiment with Python, check to see if a statement does what you think it does, but script is the way, after we are past 1 or 2 lines of code, we write it in files and then run it separately. So there are a couple of basic patterns, and it's really important to understand each of these patterns, and like I said, we'll teach you these patterns separately, and then we'll combine them together. And when you combine them together is when you say, oh, that's what a program is. So you have to suspend disbelief. We have a couple of different patterns. One is a sequence of steps. Do this, then do this, then do this. Conditional is like skipping something. Repeated does it over and over and over again. Computers are really good at repeating stuff, much better than people. People get tired going over and over doing the same thing. And then we have store and repeated steps as well. And so if we take a look at this, and we take a look at a Python program, this is a piece of code, this is a little script. If you type this into the code, take this code, Python code, into a file and ran it, it starts at the beginning, and then it goes to the next line, and the next line, and the next line. And Python executes the scripts as you write them. So it says stick a variable to, find a place called in your memory called x, stick 2 into that, okay, then go to the next one, print that out. So the program is producing output. Now go read x and add 2 to it and stick it back in x, so x is 4, then print that. This side over here, this is called a flowchart. I'm not going to make you draw flowcharts. I'm only going to draw them a few times in ways that I think will help you. But you can think of it as Python, when it finishes something, it goes on to the next one, unless you tell it otherwise. Finishes this, goes on to the next one. Finishes this, goes on to the next one. Finishes this, and now the program is all done. And so that's sequential steps. You just type them in, Python runs it. They're important, but sort of uninteresting, because you can only get so far, and you can't really make them intelligent because it's always going to do the next one. So the next thing we do is what are called conditional steps, and this is where it starts to get intelligent. I mean, where you are able to encode your brain into the computer. Like, oh, wait a sec, let's only do this step if something is true. And the syntax that we tend to use here is the reserved word if. Okay? And so the if is like a fork in the road. You can go one way or you can go another way, and you're asking a question. So inside the if statement, right here, there is a question saying, is x less than 10? That resolves to a true or false. If it's less than 10, that's true. If it's greater than 10, it's false. And so then what we do is, if it's less than 10, we have this indented block of code. There's also this colon that tells us we're in the beginning of an indented block of code. And so what it basically says is, if this is true, run that code. If it's false, skip that code. So it can either run it or skip it, depending on this question that's being asked. Now, if you look at this code, it's pretty obvious what's going on. It comes down, x is 5. If x is less than 10, that's true. So it runs this code and prints out smaller. And then it comes back here, it de-indents the next basic sequential. This ends up being kind of a block. If x is greater than 20, if x is greater than 20, oh, come back. If x is greater than 20, this turns out to be false because x is 5, and so it skips this. So the bigger never comes out, and then it continues on and prints fini. Oops, that's a typographical error. Make that a lowercase print, and then prints fini. So it comes in, runs this, skips this, and then finishes. Okay? So here is the last one we'll talk about, the repeated steps. We'll get back to store and retrieve later, but for now we're just going to talk about 3 of the 4. This is another program, and the key is that we're going to use this same choice where we're going to go in, but then we're going to run for a while, and then we'll have an exit condition where we get out. So this is a repeated over and over and over and over again, and this is the essence of how we make computers do things that are seemingly difficult, while that are more naturally difficult for people. Okay? And so how do we encode this notion that we want to do something not forever, but for a while? How do we encode that notion? And so we do it in this way. So we have our statement, sequentially go to this while. While is a keyword, and it's asking another question that's a true-false question. Is n greater than 0? I read this as long as n remains greater than 0, keep doing this indented block. And you have a colon at the end, and then you have 2 lines of code that's indented. So that tells us what the loop is, and then this is now de-indented. And so it comes in, and if this is true, if this is true, it runs these two lines. Prints out n is 5, and then it says n equals n minus 1, which makes n be 4, and it goes back up, and it goes up and it asks this question again. Is n greater than 0? If it is, continue on, and prints 4, and then subtracts it, and it does that. 4, 3, 2, and prints out 1. Then it comes up, and now after this, n is now 0, and n is no longer greater than 0, so it takes sort of the exit ramp and goes down here. So it takes the exit ramp and goes to here and runs the next line. Now, we're going to cover all this again. So I'm just trying to give you the big picture. Next couple of chapters, we're going to hit all these things again, and we're going to hit them in much more detail with a lot better information. This is now sort of like combining these. And again, I don't want you to really like know this stuff. You will know this in a couple of weeks. You will see this program again. But this shows you how we combine those patterns of repeated, sequential, and conditional together. And so this is a bit of sequential code. Comes in here, runs this, which happens to ask for a file name. Then it opens the file. It creates a data structure called a dictionary. This is all sequential. Now the for is another form of loops. So this is going to loop for a while. And then this is within a loop. We can even have 2 indents, and that's another loop. So these are like repeated. And then it goes down to the next sequential bit. Then it does this. Here's another loop that's going to run, and then here's a conditional it's going to run. And then when it's all done, we print out the last thing. And this is, of course, is the program that does, it figures out the most common word and prints that most common word out. And so this is a Python short story. It reads some data. It reads the name of a file. It opens that file. It talks about how to make a histogram. And then it looks through for the most common word. So don't worry too much about this. Over the next couple weeks, we'll fill in the pieces so that you absolutely understand every single line of this code. So this is a quick overview of Chapter 1. Stick with us. You realize it will be Chapter 7 before this makes too much sense. You really have to trust that you are learning important things and that it all makes sense when we bring it together like in Chapter 7 in a few weeks.